Alright, so this is the last section in this chapter, section 2.7, and what we're going to be looking at is we're going to be looking at two variable inequalities, which is kind of expanding on what we did with inequalities previously, but if you remember before when we would graph them, they would be on a number line. Okay, they would be on a number line, and then we would say which direction they're going based on just a normal number line. What we're doing now is that we're going to be attaching it onto a coordinate plane, and we're going to be graphing linear functions or absolute functions or some sort of functions that then we will be shading either above or below the line or above or below the function based on the inequality that's given. Okay. So the first thing that we have is that we're going to be graphing these linear functions, and it's still the same process that we've done before. You identify where your intercept is, and then you move up your slope. So here we see our intercept is at -4, so that's why we start at -4. Our slope is 3, so we go up 3, 1, 2, 3, and then we go over 1. That's our second point, and then we draw our line. Now if we want to take this and put an inequality onto it, okay, we're going to be shading. And anywhere in this green region right here, that region I just kind of shaded in, if you pick any point there and you plug it into this inequality, it's going to come up true. So let's look at the point 0, 0. Okay, right there at the origin. It's in that green section, 0, 0. If I plug in a 0 in for the x, I get 0 minus 4, which is -4. Now, the y value was 0. Is 0 greater than or equal to -4? Yes, it is. So as you see, it makes sense. So instead of just finding numbers on a number line, we're finding a space on a coordinate plane that has all these points agree with this statement. Now, with these functions, we have our dotted lines and we have solid lines. If you ever have something that's just less than or it's just greater than, and it is not, I'll repeat, not equal to, okay, so as you see with those, then it's going to be a dotted line. Okay, it means that we go up to that line, but we do not include that line, okay, because it's not equal to. So anywhere along that line are not answers. Okay. If it is equal to, so less than or equal to or greater than or equal to, then we will be including it. So this is yes, we do include the line, so we do a solid line. All right. So that's the difference between dotted lines and solid lines. So if your inequality has a solid line in it, i.e. this greater than or less than sign has a solid line at the bottom, so if it has it on it, then it will be a solid line. If it doesn't, it's a dotted line. All right, now shading. One of the things I like doing with shading is that I look at the y-axis. And once you graph everything, so once you graph your line, you'll look at the y-axis and then you look at your inequality. As you see here, this says that y is less than x. So you look at your inequality or your y-intercept and you go, okay, I'm going to shade the part that's got the point that's below it. So as you see, 1 point below the origins here, so I'm going to shade all this region. And then if it's saying that y is greater than x, then we're going to shade everything above that point. Okay. Another way of doing this is to pick a point. So if, let's say you don't know which one it is, then if you have your original function, you can pick the point, let's say like right here. We've got 0, 2. You can plug in 0, 2. If it works, then you shade that region. If it doesn't, then you're going to shade the other region. That's kind of another way of helping you check. Alright, so now graphing these. So the first thing you have to do here is that you're going to have to get it equal to y. So you got to go y is less than or equal to yada yada yada. So move the 4x to the other side, divide by 2, getting us a y is greater than or less than or equal to a -2x plus 2. And now we're going to graph that function. Okay. Well, the first thing is, okay, is it a dotted or a solid line? Well, it's going to be a solid. Okay. So it's a solid line because it's equal to. And then are we going to shade above or below the line? Well, since it's y is less than, it's going to be below. Okay. It's going to be below the line. So then once we graph it, as you see, we shaded below the line. Now the next one we're looking at, it's already in its function, so now we just have to graph it. So its y-intercept's at -5, so we start at -5, we go up 2/2. And now is it solid or dotted? It is going to be dotted. Okay. And then do we shade above or below? It's going to be above because its y is greater than. And as you see here, it's shaded above. All right. All right, now the next thing is the absolute values. Now an absolute value, remember, it makes that nice V shape. Now absolute values can go in both directions. Okay. It can either be opening up or opening down. Now with your shading, what you're going to look at is if its y is less than the absolute value, you're going to shade below it. So for this first graph, it's on the outside of the V. But if it's already pointing down, it's on the inside of the V. And then for the next one, if it's saying y is greater than, then you're going to shade above it. So in this case, it was inside the V, and then if it's opening down, it's outside the V. Okay. And again, to check, you just pick a point somewhere inside one of those regions and sees if it works out. All right, your IRAT, you're going to have to graph these three functions. The first two are linear functions, and the last one's a absolute. So make sure you identify if it's a dotted or solid line, and make sure you get your shading down. All right.